everyone, this section we will talk about AI, deep learning, especially history and future. It's very important to know the ongoing progress and the development for the future. But sometimes we move forwards back to us to use a backward thinking to, to review what we can do better and what the risk we can avoid. So let's start from the history. So talking about AI history, it's nearly a history of the human technology development. So I found a very interesting information website here. It's called History of Information. Um, so, uh, so you can have take a look with yearly arrangement for the technology development. So it's something all about the tool. Okay, different, different era. Or we can say that the era we have different tool development, but every few hundred years we will see a very advance, a breakthrough. The breakthrough, honestly, it's not easy to say where it's come from. But sometimes the breakthrough stop. Sometimes the breakthrough can continue. So it's finally we scientists find if this technology can, help the society become better. That is, people can, not to fight each other, not to destroy each other, but to help each other, to manage the world better. So that technology will, just continue developing. Otherwise, a culture even can be destroyed. So that's some history of some past history we may learn. So for AI future, the first thing we need to be very careful is the technology help us to help each other, help us to manage the world better, not to, destroy us and not to owned by only a few people and a few companies. So that's is the key to retain the technology. And if you survey the technology, you can also find around it's have a very big breakthrough around the 17th century. Here, we already have some very powerful printing technology, so people can, just to share the knowledge. So once people can start to share the knowledge, the technology growing faster than faster. So we can expect that because today we have internet. So also through this AI training, so it's also a channel to share the technology. So the technology can be shared, it can be improved. So let's start from some very powerful thing invented in the 17th or 18th century to discuss, to start discuss, the past 100 years, the very important development related to our AI involvement or improvement. So let's go back to the slide. So in 1642, there's a man called Blaise Pascal. Okay, Pascal. In the past history, also one thing is very important is a tool. So we need a tool so it can do a better automation. Always, automation is the key. It's a process because when we are asleep, the machine can still do something, or it can speed up the process. So the Pascal invent a machine, use the gear that can do the aiding and subtraction automatically, just use the gear operation. So it comes with it's just like today's screen, but actually it's only a gear. It shows digit from 0 to 9. So it comes with 6 digits. So you can add and subtract the digits from the machine. But this is you need to rolling the gear by your own. This comes with no extra power, but it's a early improvement that a machine can automatically to do the calculation. So the very big progress or improvement is on a machine can do a great amount of calculation. Once it is developed, then we can do everything smoothly because we have math, we have algorithm, then we have data, but we need something help us to process. Okay, so the tool is very important. Then in 1773, Phillips Malthus-Hand also invent. It's a full function. It can not only do adding and subtraction, it can do also multiplication and division. Okay, so sometimes we think math, sometimes you can see calculus is so complex, but eventually it's nothing but 4 operations, right? It's nothing but adding, subtraction, multiplication, and division. So once a machine can do that, and gratefully do a lot of digits, then it can help us to do a lot of things. So now you can see it comes with more digits. It can do 10 digits, okay? And even you can think it can do a floating point, okay? So that's a big progress. And this is very funny because these two people are priests. They're working in the church. So I think they got some idea maybe while they're praying. I don't know, but it's just good to start to invent the tool. And this is open. Today you can go to the library to see their schematic design of their framework. So there is also one thing very important to know, that is to share knowledge so people can do more progress, to do more improvement on that. So that's something happened very important to the AI history, because we have tool can help us to do the calculation, okay, to compute something. So you can say that's very, very, very earlier of computer. It's not by electronics, it's by mechanical, but still it can do the calculation. Then comes with the near 100 years, we have electronic devices. So that's a big progress, right? Because we can calculate things faster, and we can also save the data in some storage. So it's become more, efficient to do the calculation for our algorithm. So there are few people we have to mention. They are hero in our AI history. I think it's very good for us to, to respect them, to understand their contribution. The first is Alan Turing. Okay, today we still have the biggest computer area prize called the Turing Award. Okay, so who won the Turing Award? That's that in the computer area, that's your top layer people. So Turing is the one to propose the Turing test. Okay, so it's a judgment for artificial intelligence. So if that's the machine is intelligent enough, so it can pass the Turing test. The Turing test, actually, you can see these figures. We have a people sit here. It's a real people. It's called an interrogator. Okay, it's blocked by some certain kind of facility, maybe a wall. Okay, maybe a distance. So it's only limited to using the response to written question, okay, for A and B. So the A and B, one may be a real person, and another may be a machine. So this is a judge if the interrogator cannot distinguish which one is computer and which one is a real person. Then we say that this intelligent machine passed the Turing test. Today, we may say that a lot of large language model already passed the Turing test. But there are still some limitations here we can think. So my question for you is, what's the limitation of the test? To test a real intelligent thing, if we only use this way, is never not? You can think that. We will answer that or provide some thinking way or thinking hint later. But let's go back to the AI history. Another person called Arthur Samuel is also a very important person because he's the one who, is the earliest person to provide the term machine learning, okay? And how he do that, he's teaching computers to play checkers. This is very important because usually there are two people, a group of people plays games, right? But if one person becomes a computer, so the computer need to have the capability to calculate, to think. So more important thing, he need to learn different behavior, different patterns on that game. So he just start to use the term machine learning is what we use a lot of today, ML, machine learning. And the third person I want to mention is Marvin Minsky, and he is the one who first mentioned perceptrons. Okay, so the perceptron is the foundation of the neural network. We call neuron. A neuron can, calculate something. It's a node. It's nearly a node that can take input and do some calculation and output something. So he's the one to first address that. So we can say that's a foundation of neural network today. And the first person is John McAfee, okay? And he is the one first, mentioned the term artificial intelligence, and also have a group in MIT to start, the academic research from different universities. So they start to, to just move on to push the artificial intelligence better and better. So that's a very big event. So that's the first person I want to mention. So these four persons have a great contribution for our AI history. So Turing test, I just asked you what's the limitation of the test. One thing I want to give you a hint is because the interrogator is limited only to use written. So it's not a real person, right? A real person can talk and can do some actions. Okay, so the Turing test is good only for some language model. So that's why the large language model OpenAI already passed the Turing test. But we can't say that's a real intelligent, right? So in the later of this section, we will talk another topic that's called general AI. Okay, so general AI means the artificial intelligence can become a man to do what we can do. So Turing test is only a test to test if the machine can act like a human to respond questions. Okay, but that is already very good. Already very good because the Turing test. Turing mentioned 70 years or 80 years ago, but after this 70 years, okay, finally the OpenAI or other language model passed the test. Okay, that's a very important milestone. The next person I want to introduce you is a hero for today's deep learning. That is our core, part of this course, right? So the first person I want to mention is Geoffrey Hinton. That's always say the godfather of the neural network. He is one who developed or invent the backward propagation, which we mentioned earlier in this course, because the backward propagation is really the foundation and the core of neural network, because once you use the backward propagation mechanism, you can use gradient descent calculus to derive the weight, which is all the parameters. So that is the foundation. The second person is called Yang Li Kun. He's from France, but he has a Chinese name. And he's a student of Geoffrey Hinton. He invented convolution neural network, which is CNN. CNN is a huge progress, because if we don't have convolution today, we mentioned we need even far more big, far more deeper neural network. Okay, so convolution is a very efficient way to just make the parameters become less, a lot of less than if you don't use a convolution neural network. And convolution is also good to find the features, okay, so, and can reuse those features. So it's a very good mechanism later for transfer learning. So we can use some pre-trained model, pre-trained data set, and to learn new things. Okay, so which is also very important. The third person I want to introduce is Li Feifei. He is the one we mentioned about to talk about data at some point is more important than algorithm itself. Okay, because once we have the algorithm, we have to learn, right? For a convolution neural network, we have to learn feature maps, right? So we need to have a lot of data. So he created a project, ImageNet, which is the most powerful, I think, public data set today. So that's a very big progress for neural network. The fourth person I want to mention is Andrew Wenda. He's from Singapore, but joined Stanford, and later, a few years later, joined Google Brain, and now he found several companies. So he's also very important, because Google Brain is the first, very big operation to learn a lot of YouTube videos. We don't have to provide any rules, right, for neural network, but it's just learning, learn a lot of images. So the Google Brain simulation we read here was exposed to 10 million randomly selected YouTube video, okay, and it's just let the machine really like a person to see this video footage. It only do one thing, to recognize cat or dog. Okay, so it's a hard work, because today's neural network, we don't need to give it any rules. It's just start to learn, use backward propagation to update the weight, use convolution to generate the feature map. Okay, but you need a lot of computing power. So he is the one who started to use GPU. So the Google Brain used 16,000 computer processors with 1 billion connections to do the chaining. So it's just proof that if we have enough data, okay, if we have enough data, we have different kind of cat, different kinds of dog. Eventually, the machine learning algorithm itself can, recognize which one is cat and which one is dog. But that's hard, right? For human, we don't need a second, right? We can just, it's a cat, it's a dog. But for machine, it takes time, but you just need a right computing facility, which is, we talked about earlier, a right tool, okay? So that's some very big progress in the AI history. So here is my question. What is the progress in the past development on algorithm, tool, or data? So we can think the course we have taught different algorithm, okay, different improvement of the algorithm, and we have taught different tool, okay, and eventually we have a very powerful GPU and NPU, and we talk about different data sets. So that's the data. So the algorithm is still improving, the tool is still improving the data. We have big data right now, so we can really expect that the AI will have a big improvement in the upcoming decades. So we can continue to see this development and this improvement. Another thing I want to talk about is AI future topic. The AI future, one thing is very important that the neural network is one thing we want to copy our mind, that is mimic our mind. We have neuron. So there's a very important research today want to mimic our brain. So this is an important person called Jeff Hawkins. He's the one who invented Palm, which the Palm device is the first mobile device 10 years earlier than iPad. Okay, so he's a very smart guy. He right now jumped into the AI area to want to do some breakthrough research. Okay, so he said that we will never have true AI without first understanding the brain. Because we know that right now the neural network, we call it neural, but actually it's not our brain. It's only copy a very, very, very small portion of a brain operation. So this research is really try to understand more our brain. So to understand our brain, we can talk a little about the neuron. Okay, so here is a very important element in our mind. We have a neuron. Okay, so we can read that the human brain contains over 80 billion neurons. Okay, neurons work like little batteries. Okay, building up charges by moving iron through membranes. So it's a facility can charge and process the information. And a connection between two neurons is called a synapse. A synapse allows one neuron to pass signal to another neuron, much like a transistor in electronics. So in our mind, we have a smaller charger, battery charged computing entities, and through these entities, we have synapses to pass or not pass the signal. It's like transistor, and it's really the foundation of electronic circuit. Right? So that's the first thing I want to mention. The second thing is all these neurons and all these synapses construct our cortex. Okay, so its operation, it's very powerful. Okay, so there are estimated 20 billion neurons in the human cerebral cortex. Okay, so because the neurons connect by different network, form different networks. So we have 60 trillion synaptic connections. So this is, if you think this is transistors and mapped to a CPU circuit, so nearly a human brain is computing power is about 34,000 i7 Intel CPU. So our mind is super, 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 super powerful, we still don't understand quite a lot on our brain operation. So this is a new AI research area. It's called A Thousand Brain. A Thousand Brain tried to understand more our brain working, not only the neural network, because neural eventually is not our actually our mind operation. It's only borrow the concept of process input with something and the output, and the process is called activation function. Actually, it's not our brain. So it's only borrow the concept. But A Thousand Brain is really a direction, want to mimic our brain operation. So the researcher found that in our mind, for one fact, we have 1,000 perceptions. For example, our eyes see a cup. Okay, we may have different simple feature, finally comes with complex features. Then we have a skin to touch the cup. So we have other brain to remember different kind of feelings of our experience on handling those cups. So that's why when we see a cup, we take it. In our brain, we already have 1,000 brains to run thousands of models to do that. Okay, so that's something very, very different to today's neural network, right? So how to construct these 1,000 brains? Concept into a real framework. Scientists still doing that, but I just want to mention neural network is really a very, very early in AI. It's very early in the AI, so we will have more, need more breakthrough on that. One thing we need is the AI still don't quite understand the physical world. So our brain understands the physical world. We touch the cup, okay, we can measure the weight, we can measure the shape, and we have the eyes, we have the skin, we have our ear, we have nose. We have 1,000 brains to feel one thing, but today's AI still can't. So that's something we are in the progress. So the final topic I want to talk about is called artificial general intelligence, because today's neural network is still limited by the neuron operation, backward propagation, those things, and comes out with different models, right? But we actually need only one model like our human brains, and that can become a thing like a robot. It's like human, and when you say you say one instruction, that robot can understand using one model, one general model to do all the things. So we have some definition of the term here. So today's AI is called artificial narrow intelligence. This is most common type AI today. It focuses on specific task. Okay, just like one model do image recognition, one model do natural NLP, natural language processing, one model for data processing, just like a random forest in machine learning. So today it's only an ANI stage, but AGI possesses human-like intelligence, and can perform any intelligent task that a human can. Okay, so it's capable of learning, reasoning, adapting new situations. Okay, so if a robot going on the road to see different kind of a situation, different kind of reactions, can just like a human to use a thousand brains to absorb those knowledges, those feelings, those touches, those physical world response. Okay, so that's called AGI. But the scientists also provide another term called ASI, artificial super intelligence. So that's something human wants to make a thing greater than human. Okay, ASI suppress human intelligence and can potentially solve problems that are currently beyond the capability of a human. Think for some area, ASI can happen, but in my opinion, it's only for some area. Just like artificial intelligence can always process more information than we can, right? And to use human eyes to recognize cancers, we are tired to just recognize a lot. But if ASI, he trained very well, he can recognize cancers very well. So that's different terms on today's AI. So that's also draw a milestone from AGI to ASI. So here is the label definition. Okay, also from Google. So it's different levels of AI according to capabilities. So it comes with 5 levels. Also, the categorization is based on what we mentioned about the ANI and AGI. So we have a narrow definition and we have a general definition. Okay, so that's first read some sentence here. So what is AGI? Generalizing ability. AGI can transfer knowledge and skill learned on one domain to another, enabling to adapt a new and unseen situation effectively, just like I mentioned earlier. Okay, and AGI has a vast repository of knowledge about the world, including fact, relations, social norms, allowing it to reason and make decisions based on the common understanding. So the AGI, I use a very, very simple term. It's nearly a real people. You understand the physical world. He can learn new things, like a baby, learn new things. So that's a new GI. But today we just use the two direction to think the AGI. One is narrow, one is general. Narrow means if we put the AGI in some specific area that we think in that area it can achieve certain level of the percentage that like human. Okay, so you can see the level 1 level 1, we can say that it's a simply rule-based system. Okay, just like we ask ChatGPT one thing, it can answer us. So it's just like level 1. And level 2 is achieve 50% of skill output. Okay, for narrow direction, just like today's smart speakers, Alexa, Google Home. Okay, also LLM for a specific task. Okay, but there is no general. We said AGI today in level 2 because there is no physical world understanding that AGI can perform 50% of things human can do, because the artificial intelligence today is really have a lot lack of understanding the real world. Okay, and then level 3, beyond level 3, you see the general one, not achieved, not achieved, not achieved. Okay, only the narrow one. Okay, so level 3, just like 90% of human. For example, for narrow thing, for specific task, Today, the spelling and grammar check, okay, the machine can do very, very, very good. Okay, even around, I think, better than 90% sometimes. Okay, and for level 4, for narrow 1, it can have 99%. Okay, like human can do, just like AlphaGo. For narrow 1, for play game, if it change a lot, the AI can do very good. But for general, there's no AGI, right? Because right now we don't have anything can just act like a human. So that's a progress of the future AI to achieve the AGI, to have a AI, a robot do what we can do. We still have a lot of progress. So that's something I want to share with you. So here comes with some conclusions of this section. Okay. So the first is deep learning use very little knowledge on neuron behaviors. Okay, so today we say neural network, but still we don't understand much about brain. So that's why we changed to deep learning, right? We still have a lot of question we need to understand in our human brain. The second thing is different AI models have to coordinate together to reach next level of AGI. Just like I mentioned, today's AI is a task specific. You do one thing, you need that model, another model, different model. But actually, we need a model just can do everything. It can learn, it can react. It's a little like the thousand brain concept. It can just absorb the knowledge and use thousand brains, of conceptual mechanism to understand different things, to learn different things, and to react. The final thing is most important thing to this course, especially for edge computing, that is physical world knowledge is still insufficient for AI to solve real world problems. That's why we have this course. Just combine edge computing and deep learning together, because the next progress of AI is we let the AI to understand more about the physical world. So edge computing is the key, because we put all the different kind of sensors, and it can learn things or it can inference things at different areas, so we may collect a lot of knowledges everywhere. So I think to have a big improvement to AI right now, we need to let the AI to understand more about our physical world. But to the end, I want to provide an image for this course. Is really from the very big, very famous picture that's God created man. Why I use this picture? Because we want to have a super powerful AI. For what? Sometimes I think we need to use a backward thinking. Why we need AI? Why we need AI? We need to back to our value of every person. If we create an AI, but we devalue for person, that's not the right direction. We create AI because we know there's something great in us. There's something great in our brain. We still don't understand our brain. So we respect that design. We respect the human value. So we create or invest something, but we respect the value of human. That's the right direction for our AI improvement. Okay, so that's the end of this section.